So yes, my name is Rogan Dawes. I work for a company called Orange Cyber Defense. We are the SensePost team that, that was recently acquired by Orange Cyber Defense. SensePost ourselves has been involved in the information security arena since 2001 actually. We're based in South Africa and in the United Kingdom. Yeah. So let's do a little bit of an archaeological expedition into the sort of history of what came before USB and why USB was such a great idea or so important. So historically, and I don't know how many of you have used computers that go back this far, we had a number of different peripheral interfaces that we could use to connect devices such as modems, joysticks, printers, keyboards, and mice. We had just RS-232 serial ports that we had mice connected to. We had PS2 keyboards. We had modems connected using RS-232, and we had joysticks connected using game ports. And of course, the printers connected using parallel ports. And all of these connectors were different to start with, which meant that you always had different cables, and maybe you were going to run out of ports if you wanted to connect two printers to your computer. You were always in a difficult situation. The implication, though, about having all of these different connectors is that there was generally no automatic configuration of the peripherals that you plugged in, apart from keyboards connected using PS2 and mice connected using PS2, because those were ports dedicated for just that purpose. But for other devices, such as serial mice, serial modems, serial printers, joysticks, and other printers, there generally was this administrative overhead that was required in order to get the device working, specifying which printer, which port the device was connected to, as well as loading device drivers from external media, the old floppy disks, and so on. That was a sort of common experience for those of us who had to work through these times. And so this administrative overhead was really painful, and there were many, many drawbacks to having all of these different peripherals, peripheral interfaces. And so now we've got USB, and the situation is vastly improved. We've got Type A, Type B, Type Mini A, Type Mini B, Micro A, Micro B, USB 3, Type C. And actually, I'm going to claim that this is a vast improvement. So even though the connectors are different, they're all electrically compatible. So you can convert from one to the next using a simple dongle. But the main thing that led to what I claim is an improvement in the situation is the USB device classes and the device descriptors that every single USB device has to implement. And what this really means for us is that we can plug in an arbitrary USB device, not knowing anything about it, and we can interrogate that device using our computer to find out who made it, both a numerical identifier as well as a textual identifier. We can find out what device it is, again, a numeric product identifier and a description, as well as detailed information about what the device claims to be. And those claims will generally be one or more of a USB device class. The device classes are things like human interface devices, keyboards, mice, joysticks, and so forth. Mass storage devices, USB flash drives, CD-ROM drives, external hard drives, and the like. Maybe a printer, an audio device such as an external sound card, or it could be a webcam. And so being able to identify what the device is and what interfaces it claims to provide gives us the ability to automatically install drivers for these devices. You don't have to go, oh yes, I've just connected a Samsung printer, and then I need to go and say, oh yes, well it's the SCX 4300, so let me go down this list of printers on this driver disk and choose the right one and hope that it's actually there. What we found now, or what we are experiencing now, is that operating system vendors, the Microsofts, Linuxes, Apples, etc. of the world, have implemented class drivers, which have a generic driver for each class of USB device. And so in many cases, we can plug in an arbitrary USB device and find that it actually just starts working without any fiddling or configuration required. And so over the past 20, 25 years or so, we've managed to move from plug and pray and hope that it functions to the sort of ideal utopia of plug in a device and it just works, which is a wonderful situation to be in. I think most of you will agree. Unfortunately, with that ease of use comes people looking to abuse that for their own purposes. So let's talk about some of the ways in which USB devices have been exploited or abused to attack systems. One of the early forms of attack was made use of the mass storage devices, so the USB flash drives and the external hard drives and so on. Moving a device from one machine to another, you could trigger an automatic execution of an application that was loaded onto that flash drive, making use of an autorun.inf file. And now with 20 years of hindsight, we can see that that's clearly a terrible idea. But in the early 2000s or late 1990s, this was considered to be the height of user-friendliness, that you could install software onto a flash drive, you could plug it in and it would automatically load the installation program for the particular application, or whatever it was that the flash drive creator had decided to do. And naturally, people used this to execute and distribute malware. They would copy a autorun.inf file onto any flash drives that were plugged into an infected computer, copy itself over onto the flash drive, and then whenever that flash drive was plugged into another Windows computer, that application would get executed and spread onto the further victims. And so Microsoft killed that feature after a while, after it had been abused, but left it enabled for CD-ROM drives. Now, of course, I think the supposition was that people didn't have access to create their own CDs very easily, but before long, writable CD-ROM drives were also a thing, and this was being exploited there as well. And finally, this then led to a vendor creating a standard called U3, which was effectively a CD-ROM, sorry, a flash drive that appeared to be a CD-ROM. So it would enumerate as a CD-ROM, even though it was just a plug-in flash drive, and would still make use of these auto-run features. And of course, that was abused as well. Around 2009, 2010, ThinkGeek came up with a novelty device called the Phantom Keystroker. The Phantom Keystroker was intended as a frustrate your friends, annoy your enemies kind of gag device. That was a keyboard that would randomly turn on a caps lock key, move the mouse around, and type random keystrokes to annoy whoever it was that you had plugged this into their computer for. But a guy named Adrian Crenshaw quickly realized that there was a huge amount of potential in this, as well as Darren at Hack5 and DigiNinja got together and created, Adrian Crenshaw created the programmable HID USB keystroke dongle, and Robin Wood and Darren Kitchen at Hack5 created the USB rubber ducky. And those allow you to create a programmable keyboard that would type out a particular payload or sequence of keystrokes. And that could be used to very quickly type out an exploit onto somebody's keyboard. For example, pressing Windows R, running command.exe, and then downloading some content from the internet, or some malware, and then executing that on the victim. So it would take just a few seconds, and then you could unplug the device and walk away, leaving this malware running on the computer. And so this was a very effective attack, and it still is quite effective, although possibly less nowadays because of network controls and things like outbound HTTP filtering and so forth. In 2016, taking a bit of a jump, talking about different categories of malware. So we've talked about mass storage, we've talked about human interface devices, and now we're talking about USB network interfaces. So in 2016, a guy named Sammy Kamkar introduced a technique or a tool called Poison Tap, which used a USB network interface and an extremely broad DHCP lease on that interface to trick the host computer into routing all of its traffic via the Raspberry Pi. And this allowed interception of clear text network protocols, such as HTTP, but also SMB and so on. This would allow the Raspberry Pi to steal cookies and deliver persistent cached HTTP pages to the browser, assuming that one was running and making regular requests over the network. And having this ability allowed the Poison Tap device to capture those cookies and reuse them for, on a separate machine, pass those over to the attacker. And because they were cookies rather than credentials, in many cases, those cookies would just allow the attacker to authenticate as the victim to whatever websites that computer was trying to connect to. And of course, who could forget the NSA Ant catalog, which was revealed by Edward Snowden around 2013. This included details of devices such as the Cottonmouth 1, 2, and 3, which were designed to provide wireless access to a USB cable for the low price of $20,000, minimum quantity 50, making a $1 million purchase. And this device, although we don't have all the details of its capabilities, appears to have included a USB hub so that the device that was connected via the cable would still function at the same time as the cottonmouth device being able to implement whatever functionality it was programmed to do so. For example, mass storage or human interface device. Keeping in mind that the cottonmouth or that the Ant catalog dates from 2008, so very early days of USB security. And before we have things like block lists for mass storage devices. And of course, there are a bunch of variations on the same basic themes. Mass storage attacks, human interface device attacks, network interface attacks. One of the variations was bad USB, which was able to reprogram an actual flash drive to enumerate on the host or to the host as a keyboard or as a network interface. And so this allowed for innocuous looking devices to be repurposed with malicious intent. So the current situation, going back to 2016, I presented a tool called USaBUSe at DEF CON in Las Vegas. We commissioned some custom hardware that was based on a dev board that I found from a company in China. And in 2016, we presented our custom hardware that provided essentially USB rubber ducky capabilities, but with a Wi-Fi interface as well. And what this allowed to do, which I think is quite innovative and still is relevant today, I think. So firstly, it incorporated a mouse jiggler to avoid screensaver activations. It was very subtle. It moved only one mouse unit left and right every few seconds. And in doing so, it allowed the victim computer to remain asleep if it was previously asleep, but would prevent the screensaver from activating if the machine was unlocked, which I thought was an interesting variation. I think the 1 pixel movement was considered to be too small to wake up the machine, but enough to keep it awake. Secondly, with the Wi-Fi interface, it provided a means for remote triggering of your payload at a suitable time. And what this really meant is that in contrary to the USB rubber duckies, where you could program a fixed delay or none at all, you could actually watch to see when this device was plugged in. You could watch to see when would be a good time to actually launch your attack. So while the victim is away from their computer and their computer is locked, then you could approach and plug this device in, wait for them to return to their computer, watching from a safe distance, and then when the computer is unlocked and they've turned their head away for a few seconds, you could trigger your payload. And then finally, the most innovative feature of the USaBUSe attack is that it provided a communications channel between the victim and the attacker that was completely independent of any networking capabilities that the victim computer had. So if it had a network interface that was completely disabled or connected via all sorts of network intrusion detection and monitoring tools, it didn't matter at all, because any communications that happened between the victim computer and the attacker were actually tunneled through this USB device that looks just like a flash drive. And all of this was possible without requiring any special drivers or configuration because Windows already provided them. So this communications channel was achieved using the raw HID interface. So I've mentioned keyboards, mice, and joysticks. Human interface device class also specifies a raw channel, which simply allows users to send arbitrary bytes to the device and receive arbitrary bytes in return. And essentially what this provides you is very similar to a netcat data pipe. In its first incarnation on the USaBUSe hardware, it was limited to 8 kilobytes per second, which is not insignificant. And so it leveraged this, this data channel to minimize the on-screen time of the typed payload by downloading a more complicated script after the initial script had been typed out. And as a result, USaBUSe was able to execute and disappear from screen within about 6 to 8 seconds. Unfortunately, the USaBUSe attack chain was rather complicated to set up, and there didn't really seem to be much take-up of the technique outside of a very small pool of people. The default firmware available for the WID injector, which is the device on the right-hand side, did a similar thing, but rather chose to use a serial port rather than a raw HID interface. And as a result, this technique only worked on Windows 10 workstations due to driver issues on earlier versions of Windows. The interesting thing about the raw HID interface is that by default on both Windows and OS X is that the user has permission to access this device. On Linux, however, that permission is not granted by default to unprivileged users. In late 2016 to 2017, Marcus Mengs was working on PornPy, which brought together almost all of the previously mentioned attack types into a single inexpensive device based on a Raspberry Pi Zero, or 0W. One of its early claims to fame included capturing any SMB network hashes, cracking them automatically using John the Ripper, and then typing out the password to unlock the screen. A fully plug and pwn device. Marcus also implemented the same raw HID interface in PornPy, but in my opinion, never really leveraged it fully in terms of its capabilities. As you can see, this is part of the PornPy configuration interface, where it is able to support or implement a variety of different USB interfaces, whether CDC, ECM, Ethernet over USB for Unixes, RNDIS, Ethernet over USB for Windows, keyboard, mouse, raw HID, serial, as well as mass storage. So this is just an example of some of the ways in which people built up their PornPy devices using screens and buttons and USB stems, allowing you to plug in the device without having to use a cable. In 2016 as well, Mark Newlin published a tool called MouseJack, the results of his research into a variety of wireless keyboards and mice. He figured out that even though the key reports were encrypted between the keyboard and the receiver, mouse reports were not. And most importantly, that it was possible to send an unencrypted keyboard report to the mouse endpoint. In doing so, he was able to inject keystrokes into an existing wireless receiver, covering manufacturers such as Logitech, Microsoft, Dell, Lenovo, Amazon, and more. This was a great find from an attacker's perspective, because it eliminated one of the hardest parts of the rubber ducky attack, actually plugging the dongle into the victim's computer and having it stay there long enough to be effective. mouse jack attacks are still effective today, even with recently purchased devices from Logitech themselves. Updating firmware in the unifying receiver is near impossible because even years afterwards, there is either no updated firmware available or it is buried so deeply that nobody can find it, even when they're actively looking for it. And factories are even still producing devices with vulnerable firmware the last time I checked. In 2017 at HackCon in Norway, I met Mark Newland and learned about mouse jacking, and one of the things that he mentioned was Logitech's HID++ protocol. This is a raw HID interface used by Logitech to do out-of-band functions such as getting the battery level from the peripheral or programming macros. Of course, as soon as I heard this, I wondered whether it would be possible to implement USaBUSe style attacks against unifying receivers and get the same benefits of not requiring direct physical access to the target as the original mouse jack attacks. Unfortunately for me, I'm not smart enough to implement this myself, but Marcus Mengs completed an epic deep dive into the unifying receivers and figured out all of the necessary details. Having reported a number of new vulnerabilities to Logitech, he released Logitacker, which combined mouse jacking and USaBUSe attacks to get a shell using a unifying receiver. This tool was implemented as firmware for a Nordic nRF52840 microprocessor accessed using a simple serial terminal. And this was implemented on a variety of supported devices, which you can see on my slide. And finally, in 2019, Mike Grover released the O.MG cable coming full circle to the NSA playset and the Cottonmouth tool, implementing a Wi-Fi controlled rubber ducky in a USB cable. Unfortunately, this currently has no raw HID capabilities, so it's limited to keystroke injection only, or keyboard logging if you get his most recent cable. So what does the future hold for USB attacks? I still find through numerous physical assessments that plugging in so-called innocuous USB devices, such as keyboards and mice, is very effective. This has even been in the face of systems configured with USB control software, configured with a list of explicitly permitted devices. Setting the USB vendor ID and product ID to that of an approved device is enough in most cases to get around those controls. In the very near future, I will be releasing some changes to PROIDEA to make establishing tunnels over USB devices a much simpler matter that just about anybody can achieve. And so what I'd like to do next is show a demonstration of just how easy it is to get a shell over a USB device. So what I have is a device, Raspberry Pi or similar, that is running the PROIDEA stack. I have a victim computer on the left-hand side. My PROIDEA logs are going to be shown in this window at the bottom, and then my attacker is this whole virtual machine window inset. Okay, so our victim is the Windows machine in the background. Our attacker is the Kali instance in the foreground, in the top right-hand corner, logs in the bottom section, and then various terminals that we will use to gain our shells. So one of the things that USaBUSe does, and PROIDEA, is it gets you a shell over this USB connection. And so firstly, we need to set up something that will catch the shell. I'm choosing to use Metasploit for this, but you can use a simple netcat listener if you prefer. Just setting it up to listen on port 4444, as is commonly used. So this is the PROIDEA interface. We have our USB gadget settings, where we have selected the keyboard, mouse, and our raw head device. On the left-hand side, we have a variety of descriptor configuration, the vendor ID and product ID, and various descriptive fields. It's important to make sure that after you've loaded the covert channel JavaScript or head script file, that the vendor ID and product ID that is passed through to the script matches the device that you have configured. And so it launches the payload using the keyboard. And for the purposes of this demonstration, I have not hidden the window. It then downloaded a secondary payload and then established a command shell with my Metasploit instance. So we can see the sessions. We can connect to it. And as you can see, we have a shell and we can communicate with that remotely without causing any visible traffic on the victim's computer. And certainly nothing on the victim's networking interfaces. The next step that I wanted to show you, though, is that you can also tunnel arbitrary TCP connections over the same interface. So I have a HTTP server listening on localhost 65535 and a TCP proxy implemented in the firmware of the second stage that was uploaded. And so if I connect to localhost port 65535, I can access the HTTP server, which is running on my Kali instance, and all of this is being done over the USB head interface. So this will be released in the next few days. There's a little bit of polishing and bug fixing that needs to be done, and then it will be published on the SensePost blog and made available to everybody. And this is my conclusion. And with this, I hand the mic back over to the MC.